Okay, can you all see the PPT?
Yes, sir.
Yes,
Okay,
sir.
then let's get started. Yesterday we did the solar system, the revolution of the planets around the sun. And okay, let me ask you a few questions then. How many laws of planetary motion?
3.
Huh?
3.
3 laws. Okay, and who is given these laws?
Kepler.
Johannes
Kepler.
Yeah, Kepler. Okay. Can anybody tell me what is the first law? Yes, one line. Yes.
The planets revolve around the sun in elliptical orbits with the sun at one of the foci.
Yes, very good. Who was that?
Sahil.
Sahil. Okay, chalo, very good. Okay, and what about the second law? Somebody else other than Sahil. I want an answer. Or you can put it down in the chat. Like, what is the Kepler's second law? Yes, anybody?
Radius vector of planet sweeps out at equal area and equal period.
Equal area and equal time. Okay. Yes, Sabdar, I see your answer. So, you have to use the proper wording actually. What you're giving the answer is correct. But just remember, just try to get the correct wordings, like the radius vector. Okay. The radius vector sweeps equal area and equal time. Okay. So that means when the planets are closer to the sun, they are moving faster, and when they are away from the sun, they are moving a little slower. So that they sweep the equal area. Okay. Chalo. Okay. And what about the third one? Anybody? Or you can just simply tell me. The cube of semi-axis. Okay. Okay. Basically, the square of the period, that is their sidereal period, is proportional to the distance from the planet, basically. Okay. So cube of the distance from the planet. So square of the sidereal period is directly proportional to the cube of the distance. So that was about the planetary motion. Okay, let's go to this summer solstices, not summer solstice, equinoxes and solstices. So I'm sure now you must be knowing what is equinox and what is a solstice. Okay, so let us see some movies quickly first, and then we'll start. Okay, let me see. Okay, were you able to see the video?
No, sir.
No?
No, sir.
1 minute.
No, sir.
One.
The video is not visible.
Visible, sir.
Discuss equinox and solstice. Now, these are very simple and very straightforward topics, but still there are so many students who find it really difficult and confusing. So in this video, we'll try to understand the concept in a very simple and short way, making it really easy for you. All right, let's begin.
Okay, when I started the second video, were you all able to see it?
Yes, sir.
So I'll just start again because the problem is, we have to do the mic settings differently.
राइट, सो इक्विनॉक्स और सॉल्स्टिस को समझने से पहले हमें अर्थ के रोटेशन और रेवोल्यूशन के बारे में कुछ इंपॉर्टेंट बातें पता होनी चाहिए, जैसे कि अर्थ का रोटेशन पीरियड 24 आवर्स है और अर्थ का रेवोल्यूशन पीरियड 365.25 डेज है. नेक्स्ट थिंग दैट you must know is that the Earth's axis is tilted at 23.5 degrees and the Earth rotates from west to east. अब जो सनराइज है वो ईस्ट टू वेस्ट जाती है ऑन द मैप. अब यहाँ पर आप कंफ्यूज भी हो सकते हैं कि आप सोचेंगे कि सन लेफ्ट में होगा कि राइट में होगा. लेट मी टेल यू दैट द अर्थ रिवॉल्व्स अराउंड द सन इन एन एलिप्टिकल ऑर्बिट. इसका मतलब ये है कि कोई वेस्ट और ईस्ट नहीं है, कोई लेफ्ट और राइट नहीं है. अगर आप अभी स्क्रीन की तरफ देख रहे हो तो आपको सन लेफ्ट में दिखाई देगा, लेकिन अगर आप ऑपोजिट साइड जाके देखोगे तो आपको सन राइट में दिखाई देगा, which means that these things are dependent on the perspective of the person who is looking at the object. इसलिए आपको ये याद रखना है that the earth rotates from west to east and sunrise travels from east to west starting from Japan to Alaska. Right, so 3 important latitudes आपको पता होने चाहिए. These are the 0 degree equator, 23.5 degree north tropic of Cancer and 23.5 degree south tropic of Capricorn. Now you must have noticed that the tilt is 23.5 degrees, and we also notice latitudes which are 23.5 degrees north and south, because these latitudes have a lot of significance. इस tilt की वजह से ये latitudes बहुत ज्यादा important हो जाते हैं, because if you can see that इस diagram में जो center point है Earth का tilt की वजह से 23.5 degrees पर आ गए. So it acts as a virtual equator in this case. 0 degree equator से
Woo! Adapted mind math! Come explore the site with me. I'm in first grade, so I'll pick that.
सेंटर है, लेकिन टिल्ट होने की वजह से ये सन की डायरेक्ट रेस के इम्पैक्ट में नहीं है. आप पता है, व्हेन वी टॉक अबाउट दिस पर्टिकुलर डायग्राम एंड सिनेरियो, सन की रेस अर्थ के आधे हिस्से को ही मिलती हैं एक टाइम में, बाकी आधा हिस्सा डार्क रीजन होता है, क्योंकि ये रोटेट करता रहता है, इसलिए दिन रात ऑल्टरनेटिवली आते रहते हैं. और नोटिस करो, जो नॉर्थ पोल है इस सिनेरियो में इसको कंटिन्यूअसली अर्थ की रेज मिल रही हैं और इसको सनलाइट 24 आवर्स अवेलेबल है. सिमिलरली साउथ पोल को बिल्कुल भी रेज नहीं मिल पा रही है और ये कितना भी रोटेट करेगा, लेकिन इस ओरिएंटेशन में और इस सिनेरियो में 24 आवर्स डार्कनेस देखने को मिल रही है एट द साउथ पोल. तो हम कह सकते हैं कि क्योंकि साउथ पोल को सनलाइट नहीं मिल पा रही है, इसलिए यहाँ पे काफी ठंड होगी और इसलिए यहाँ पर विंटर सीजन होगा. और क्योंकि नॉर्थ पोल और नॉर्दर्न रीजन को नॉर्मल से ज्यादा सनलाइट मिल रही है, इसलिए ये समर सीजन होगा नॉर्दर्न रीजन के लिए. So in orientation like this, in a scenario like this, when the North Pole is facing towards the sun and the South Pole is facing away from the sun, we could say that the Northern Hemisphere would be witnessing summers and the Southern Hemisphere on the other hand would be witnessing winters. ये बहुत ही basic information है, बहुत ही basic concept है, ये आपको पता होना बहुत जरूरी है, इससे आपको equinox और solstice समझने में आसानी होगी. Now if we look at the opposite scenario, the opposite situation, when the earth moving in the elliptical orbit would have reached the opposite side of the sun. अब यहाँ पे नोटिस करो कि अर्थ का सेंटर यहाँ है और 23.5 डिग्री साउथ ट्रॉपिक ऑफ कैप्रिकॉर्न अब वर्चुअली इक्वेटर बन चुका है और सन के डायरेक्ट इम्पैक्ट में है. बिल्कुल ओवरहेड सन रेज अभी ट्रॉपिक ऑफ कैप्रिकॉर्न पे आ रही है. ओरिएंटेशन अभी भी सेम है, टिल्ट अभी भी सेम है, रोटेशन वही वेस्ट टू ईस्ट हो रही है. बट यहाँ पे एक सिनेरियो चेंज हो गया है, दैट नोटिस द साउथ पोल व्हिच इज फेसिंग द सनलाइट थ्रू आउट द डे. ये कितना भी रोटेट करे, बट क्योंकि ये सन को फेस कर रहा है, इसलिए इसको पूरा दिन सनलाइट मिलेगी एंड इट विल बी वार्म. So we can say that the southern hemisphere is experiencing summers. On the other hand, if you look at the northern pole, which is facing away from the sun, and it will have no sunlight for the entire day. और इस situation में काफी ठंडा रहेगा मतलब यहाँ पर winters है. So the northern hemisphere is facing winters in this particular orientation of the earth in the elliptical orbit. तो आपने देखा कि अर्थ की रेवोल्यूशन में कैसे विंटर्स और समर्स फ्लक्चुएट हो रही हैं. जब नॉर्दर्न हेमिस्फेयर में समर्स हैं, तब सदर्न हेमिस्फेयर में विंटर्स हैं, एंड वाइस वर्सा. Now these figures are so interesting because we get to see how the tilt, rotation and revolution are some of the important factors for formation and seasons along with climatic conditions, and these are really important for the survival of life on earth. अब कुछ और फैक्ट्स आपको बता देता हूं, that the earth travels in the elliptical orbit at the speed of 18.5 miles per second, जो कि बहुत तेज है. And the angle of tilt, which is 23.5 degrees, is as compared to the vertical angle. But अगर horizontally इसको देखें तो ये 66.5 degrees होगा, with which we can say that the angle of the Earth's tilt with respect to the orbital plane is 66.5 degrees. And this angle is maintained throughout the orbit. तो कई स्टूडेंट्स को ये लगता है कि जो एंगल है ये फ्लक्चुएट होता है. ऐसा बिल्कुल भी नहीं है. 23.5 degrees tilt मेंटेन रहता है. अर्थ की पोजीशन चेंज होती रहती है, इसलिए ऐसा लगता है कि कभी ये सन के लेफ्ट में है और कभी सन के राइट में है. बट रिमेंबर, यूनिवर्स में 3D स्पेस में लेफ्ट राइट वेस्ट ईस्ट कुछ नहीं होता है, बिकॉज इट टोटली डिपेंड्स ऑन द पर्सपेक्टिव ऑफ द पर्सन हु इज वाचिंग एंड फ्रॉम विच एंगल. हम रोटेशन वेस्ट टू ईस्ट इसलिए बोलते हैं बिकॉज हमने एक मैप डिफाइन कर रखा है. 2D मैप में चाहे आप कैसे भी देखो, वेस्ट और ईस्ट हमेशा सेम रहते हैं. अब आपने देखा कैसे सीजन स्विच हो रहे हैं नॉर्दर्न हेमिस्फेयर और सदर्न हेमिस्फेयर में, लेकिन ये स्विचिंग जो है ये सडनली नहीं होती है. दिस इज नॉट एन इंस्टेंटेनियस प्रोसेस. ये ग्रेजुअल प्रोसेस है. धीरे धीरे अर्थ अपनी एक पोजीशन से अपनी ऑपोजिट पोजीशन पे पहुंचती है और इसके बीच में सीजन चेंज होते हैं. गर्मी से सर्दी आने में बीच में काफी टाइम लगता है और हम मौसम चेंज होने की बात नहीं कर रहे हैं. हम पीक समर से पीक विंटर तक स्विच करने की बात कर रहे हैं. बहुत ज्यादा गर्मी जून के महीने में होती है, बहुत ज्यादा ठंड दिसंबर जनवरी के महीने में होती है. इनके बीच में 6-6 महीने का गैप रहता है और यहाँ पर धीरे धीरे मौसम फ्लक्चुएट होता है. एंड दिस ब्रिंग्स अस टू अ वेरी इंपॉर्टेंट कॉन्सेप्ट व्हिच इज इक्विनॉक्स एंड सॉल्स्टिस. इसके लिए हमें अर्थ की पूरी रेवोल्यूशन को समझना होगा. Right, so this is how the earth revolves around the sun in an elliptical orbit. हमने दो ओरिएंटेशंस ऑलरेडी देख ली हैं. सबसे पहले ओरिएंटेशन हमने वो देखी थी जो कि ये है, the earth which you can see on the right side of the screen, and the second orientation which we saw was this one, which is the earth on the left side of your screen. अब एक बेसिक अंडरस्टैंडिंग के लिए और ओरिएंटेशन को समझने के लिए लेट अस लेबल दिस एज लेफ्ट, राइट. Let's say this is the top view of the earth which you can see from the screen, और एक पार्ट है अर्थ का जो कि आपको दिख नहीं रहा है, which is the back side. So notice the left side in this particular orientation is facing towards the sun. Similarly, the right side in this orientation is facing towards the sun. The left side is not facing the sun. Top view फिर से आपको दिख रहा है, लेकिन आपको bottom view नहीं दिख रहा है. Now in this figure you can see that the top view is facing the sun, और left और right sun को face नहीं कर रहे हैं. Back view आपको फिर से नहीं दिख रहा है. But in this case, you can see that the right and left are not facing the sun. The top view, which you can see, is also not facing the sun, but the back view, which you cannot see, is actually facing the sun. यहाँ पर आप इस tilt को देखो. Right, so in this figure, you can see that the axis is not exposed to the sun completely. यहाँ पे सिर्फ northern part जो कि आधा part है, वो sun के लिए exposed है completely. Similarly, in this one, the left one, you can see that the southern half of the axis is exposed to the sun, but in the top one you can see that the entire axis is exposed to the sun. तो यहाँ पे जो point of contact है center, वो बिल्कुल यहाँ पर होगा, and in the other two the point of contact would be somewhere here. And we saw in these illustrations previously कि ये जो point of contact है ये Tropic of Capricorn है in the left one, और ये Tropic of Cancer है in the right one. बट ये जो बीच वाले हैं इनमें पॉइंट ऑफ कॉन्टैक्ट इक्वेटर होगा, बिकॉज दिस इज द इक्वेटर एंड द ओरिएंटेशन इन दिस केस वुड एक्चुअली मेक इट द पॉइंट ऑफ कॉन्टैक्ट ऑफ ओवरहेड सनलाइट. तो बेसिकली ट्रॉपिक ऑफ कैंसर एक वर्चुअल इक्वेटर था इस केस में, ट्रॉपिक ऑफ कैप्रिकॉर्न एक वर्चुअल इक्वेटर था इस केस में, बिकॉज ओवरहेड सनलाइट यहाँ मिल रही थी, सबसे ज्यादा गर्मी यहाँ हो रही थी. बट इन दिस केस द इक्वेटर रीगेन्ड इट्स स्टेटस ऑफ being the actual equator because maximum sunlight, overhead sunlight वापस इक्वेटर को मिल रही है in both the cases of top and bottom one. इसीलिए मौसम धीरे धीरे फ्लक्चुएट करता है. नॉर्दर्न हेमिस्फीयर के केस में आप देख सकते हैं यहाँ पे समर्स होंगी, यहाँ पर विंटर्स होंगी, और समर्स और विंटर्स के बीच का जो रीजन है वो यहाँ से होता हुआ जाएगा. This would be a situation where the northern hemisphere would be midway between summer to winters, and in this scenario it would be midway between winters to summers. और इस पीक टाइम को जिसमें समर्स का पीक आया है एंड द नॉर्दर्न हेमिस्फीयर इज फुल्ली एक्सपोज्ड टू द सनलाइट, वी कॉल इट द समर सोल्स्टिस फॉर द नॉर्दर्न हेमिस्फीयर एंड द विंटर सोल्स्टिस फॉर द सदर्न हेमिस्फीयर. सोल्स्टिस का मतलब है जब एक हेमिस्फीयर सन के लिए पूरा एक्सपोज हो जाए और उसको मैक्सिमम सनलाइट मिल रही हो ऑन दैट particular day. So this is a solstice and this is also a solstice. Similarly, equinox वो वाला डे होता है साल में जब दोनों नॉर्दर्न और सदर्न हेमिस्फीयर को बराबर सनलाइट मिलती है, दे आर इक्वली एक्सपोज्ड टू द सन. तो इस ओरिएंटेशन में हम देख सकते हैं दैट दीज टू पोजीशंस आर एग्जैक्टली सिमिलर बिकॉज द नॉर्दर्न एंड सदर्न हेमिस्फीयर आर इक्वली एक्सपोज्ड टू द सन, एंड ऑन दिस पर्टिकुलर डे ऑफ द ईयर वी वुड हैव इक्वल डे एंड नाइट. सो दीज आर द इक्विनॉक्स, इक्वल receiving of sunlight by both the hemispheres. अब northern hemisphere के respect में you can see this is the summer solstice, this is the winter solstice, और summer से winters में जब हम जाते हैं तो बीच में autumn आता है, so this is the autumn equinox, और जब winters से summers की तरफ हम जाते हैं तो spring आता है, so this is the spring equinox. और वो दिन जिसमें northern hemisphere में सबसे ज्यादा गर्मी होती है, it is the 21st of June. So the summer solstice in the northern hemisphere is on the 21st of June, whereas the winter solstice of the southern hemisphere is also on the 21st of June. Similarly, the winter solstice of the northern hemisphere is on the December 22nd. अब जब इक्विनॉक्स की बारी आती है तो एक इक्विनॉक्स 23rd सितंबर को आता है और दूसरा वाला 21st मार्च को आता है. एंड इफ यू रिमेंबर कि हमने ITCZ वाली वीडियो में भी ये कॉन्सेप्ट थोड़ा बहुत डिस्कस किया था कि कैसे ITCZ फ्लक्चुएट होता है बेस्ड ऑन द पोजीशन ऑफ द अर्थ इन द एलिप्टिकल ऑर्बिट अराउंड द सन. और ऐसा लगता है कि अर्थ स्टैटिक है और सन की पोजीशन चेंज होती जा रही है. सो वी कैन से दैट द मूवमेंट ऑफ द सन इज अपेरेंट बट इट इज नॉट एक्चुअल, बट द मूवमेंट ऑफ द अर्थ अराउंड द सन इज एक्चुअल. तीनों लैटिट्यूड्स के बीच में between the equator, Tropic of Cancer and the Tropic of Capricorn, we see that the ITCZ fluctuates in a way that it comes down, then again it goes up. So this fluctuation is nothing but the overhead position of the sun. Tropic of Cancer के ऊपर जब सन होगा, overhead जब सन होगा, उस वाले केस में ITCZ बिल्कुल Tropic of Cancer तक चला जाएगा और फिर सन की पोजीशन धीरे धीरे overhead इक्वेटर के ऊपर आएगी, which would be at the position of equinox. फिर again solstice आएगा, northern hemisphere का winter solstice, जिसमें सन की पोजीशन southern hemisphere के ऊपर जा चुकी होगी overhead on the
Okay, so did you like the movies? Yes or no?
Yes, sir.
Yes, sir.
Yes,
So
sir.
did it make it clear what is a solstice and what is an equinox?
Yes, sir.
Yes, sir.
Okay, by looking at the movies, I think it becomes very clear. But anyway, let's go through the PPTs once again, so that should make it even clear. Okay. Basically, whatever has been covered in the videos, we are just going to be seeing that in the text form. So I'll probably go a little faster. The Earth revolves around the Sun in an elliptical orbit. At the same time, Earth is also rotating on its own axis and from west to east. Okay, completing a rotation in about 24 hours. No, just try to visualize when we say it's going from west to east, and that is the reason we have the sunrise on the eastern side. That means the eastern sides will always have the sun rising first, like even in India, the sun rises in the east first. Like in the Calcutta and all, you have a sunrise earlier than the Mumbai on any given day. Okay. On any given day, the sunrise for the eastern part is earlier than what it is on the western part. Okay. So if you can just visualize this, you will be able to make out. And it's completing one rotation in about 24 hours. Since it is a spherical, only 50% is lighted and 50% dark-night illuminated sphere that we did yesterday also. Okay, let's go on to the next one. This is what was shown in the movies. Like during the June solstice, it is basically, like what he said, Tropic of Cancer is as a virtual center of towards the sun, and we are getting the direct sunlight there. Okay, and the northern part is always having the light, and the southern part is not having light at all. Okay, this is the June solstice, and this is the December solstice on the lower right one. Okay, and this is the equinox. Axis inclined to the plane of its orbit at about 66 degrees 33 minutes, because from the vertical it is inclined at 23 degrees. Okay, 23.5 degrees about, or 23 degrees 23 minutes, something like that. While the axis maintains direction space, its direction with respect to the sun changes according to the position of the Earth. So basically, because that the direction, the way the axis is, that is fixed. So that is why when it is going around that sun, that some of the Earth's portion is towards the sun, and while at other time it is the other part which is closer to the sun. Okay, like we saw in that video, if you make this fourth, especially if you try to show the summer solstice and the winter solstice, you will see at one time it is the northern part which is towards the sun, and during the winter solstice it is the or during the northern winter, it is the southern hemisphere which is towards the sun. Okay. 21st June, we recently had that, 2 days back, we had the summer solstice. On 21st June, when the north end of the Earth axis, that is the North Pole, is tilted toward the sun, the maximum amount of 23 degrees, the circle of illumination encloses the entire Arctic Circle. That means basically, on this 21st June, the whole of the northern part is getting illuminated. When you go, I think it's in second year or third year, you will go through the concepts of what is a twilight and, what is civil twilight, what is nautical twilight, what is astronomical twilight, what is the sunrise, what is sunset, and all that. So we can say if you go in the more northern parts, above 66 degrees and all, you will have daylight 24 hours. The sun, you will see the sun will never set there. Okay, or there will be twilight all the time. Not really sun, but you will have the twilight. That means a daylight over there. 24 hours you have the daylight in the most northern parts of the Earth. Okay, and whereas in the southern part, when the sun is at the Tropic of Cancer, in the southern part it's always dark. Throughout 24 hours you will have the darkness there. Okay. On this date, that is on the 21st June, the sun attains its maximum declination north, and the sun rays fall vertically over the Tropic of Cancer. The sun is then said to be at the summer solstice. So basically, on this date, I should put it here, 21st June. Actually, this day is not fixed, but generally it is around 21st June. It could be 20th June or 21st June. Okay, this is the same what we saw in the movie. But in this case, yeah. Okay, this is the winter solstice, and here we have the summer solstice. It is just turned the opposite way. Okay, the tilt has been shown the other way, or as if you are seeing the picture from the other side. Equinox, the autumn equinox is on 23rd September. Okay, there are two equinoxes. Like you have two solstices, you have two equinoxes, and one of the equinoxes occurring on the around 23rd September, and that is what is called the autumnal equinox. Okay, and the other one is called the vernal equinox, around 20th March or 21st March. So on 23rd September, the tilt of the Earth axis is in direction at right angle to the direction from the Earth to the Sun. The sun rays will then fall vertically over the equator, and the sun's declination is at 0. The circle of illumination passes through the two poles. That means both the poles are having equal light, north and south pole both. Okay, because the center is at the equator. The places on the Earth are having day and night of 12 hours duration. That is, the sun would rise at 6 a.m. So this is just an example. Okay, but still at a different latitude, it's a different times of sunrise and sunset. Okay, but the day and night is equal when the sun is at the equinox. And on 23rd September, equinox is called the autumnal equinox. On the 22nd December, the south end of the Earth axis is tilted towards the sun. That is the maximum declination. Okay, this is 23 degrees. I have to correct it. Okay, so on this date, the sun is said to be at the winter solstice as it attains its maximum declination south. The sun's rays then fall vertically over the Tropic of Cancer. Okay, so the maximum impact is at the Tropic of Capricorn, which is 23.5 degrees south. The circle of illumination now encloses the entire Antarctic Circle. All places in the southern hemisphere then have the longest day and the shortest night. On this day, on the 22nd of December, they will have the longest day and the shortest night, while places in the northern hemisphere will have the shortest day and the longest night. Because the sun is farthest away from us, So this is what will happen. And the places in the Antarctic Circle is, we can say, around the North Pole. They have the continuous. And the Antarctic Circle is the South Pole. Have the continuous daylight. Where places within the Arctic Circle, which is in the North Pole, they will have darkness throughout the whole day. That's 24 hours. They will have the darkness. Okay, this way we can see what is happening. Okay, this is the for the winter solstice that in the northern part is absolute darkness for the full 24 hours, and whereas the south one is illuminated. Okay. On the 21st March, of course, the opposite is happening, declination at 0, and that is, it is called the vernal equinox. From vernal equinox to autumn equinox, the north pole of the earth is tipped towards the sun, and therefore, in the northern hemisphere, these areas, that is the northern hemisphere, would remain illuminated for longer period and the zone of darkness for shorter period. That means from 21st March to 23rd September, because the sun is in the northern hemisphere, you would have longer period of daylight, than the darkness. There is more period of daylight and less period of darkness. Okay. And from 23rd September to 21st March, it is the opposite. That means in the northern part, we have more duration of the darkness than the light, whereas in the southern hemisphere, they will have more daylight time and less night time or darkness period. Okay, you cannot call it night, day or night, but it is period of darkness or the period of light. Okay. So if you can, it should be noted, or if you can just visualize these things, that if you have the latitude and the sun's declination same name, what is the declination of the sun at the equinox?
0.
Yeah. And what is the declination of the sun on 21st June?
66.5 degrees.
You can write down in the chat. I cannot hear properly. What is the declination of the sun around 21st June? I don't see any answers coming in the chat. What happened? Looking in the Google. I want more answers. Declination of the sun when around 21st of June. What is the declination of the sun? Come on, man, answer. I'm waiting for your chat. Answers on the chat. Where is everybody? Gone to sleep? Yes, Karthik Granthi, I think you have raised your hand. You have any question? You can unmute. Okay, let me unmute. Karthik, do you have a question for me? Yes, only got 3-4 answers. I want more answers. what is the declination of the sun when, at summer solstice, or when it is 21st June? What is the latitude declination of the sun? I am seeing only 3 answers. Quickly write down your answers in the chat. What happened, man? I'm not getting any answers. Okay. Now, yes, Safdar Khurshid, where is your answer? Siddesh, Amit, Love, Siddhant Patil, Syed Amir, Shivam Panse, Shubham Kadam, Vaibhav. What happened? All these people have only just joined and gone back to sleep somewhere, or what? Huh? Safdar Khurshid, I cannot understand your answer. What is 90 to 23 and a half? Nishant and Sandesh. Now probably some of the people have got the answers from Google. Otherwise, I got a lot of answers at 66 and this thing. Dear friends, on 21st June, the declination of the sun is 23, 1/3 degrees, or 23 and a half degrees. Sun is always moving between 23 degrees south to 23 degree north. Okay, so declination will never be more than 23 and a half degrees, be it north or south. Okay, just remember that. Just try to visualize. So that is the reason, like when the sun is at the Tropic of Cancer, that is 23 and a half degree, then it starts to again move towards the south. Okay, comes to 0 around 23rd September. Then again on 22nd December, it is maximum latitude south, maximum declination south, that is 23 and a half degrees south. And then again starts its northward journey towards the equator. Okay, so just remember, the sun is always moving between 23 and a half degree north to south, never going at a more declination. Okay, it is the way, because the actually we say sun's declination, but it is the sun is moving around. Anyway, you have to only just remember that the declination is 23 and a half degrees. Okay, let's continue. Actually, we are at the end of it. So, so that means when you have the latitude and declination same name, that means the, when the declination is north, that is between the 21st March to 23rd September, the declination is north for the sun. So that time in the northern hemisphere, you will have a period of daylight is longer, because when the latitude and declination have the same name, you will have a longer period of light. Okay, when it is opposite, the period of light is short. Okay, it is simple thing you can understand. Try to understand. Just visualize this. Where is the Earth? Where is the sun? If you move it up and down to 23 degree north and south, you will see which area will have the longer period of light and shorter period of darkness. Okay, we are coming towards the end of the today's topic, that is the solstice and equinoxes. If you have any questions, just write down in the chat. Okay, write down your questions if you have any questions. write down in the chat, or if you don't have any question, just write N in the chat. Okay, good. So I assume that all of you have understood the concept of solstices and equinoxes, and whatever the declination is at that time, what is the Tropic of Cancer, what is Tropic of Capricorn, what is at what latitude it is there. All these are all imaginary lines, but at what latitude on the Earth Tropic of Cancer is there, and what is the declination of Sun at different times. Okay. Okay, so that is all for today's topic. Do we have a lecture tomorrow also? Let me see. What? On EVS 2, EVS 3, and VPCP. Okay, I don't have a lecture with you tomorrow, but what is the progress with those questions that I had given you on that finding the vortex? Has everybody finished those 2 questions? Just type yes or no. I want to know.
Yes, sir.
Let everybody write yes in the chat. Whosoever is finished, just write yes, and who has not finished, write no, because I want to see how many yes and how many no. Or if anybody has any difficulty while solving that problem, you can ask me. Okay? Because when I'm trying to finish these topics in the unit 3, and then we'll do the practical problems on all these things. Okay? So I hope you should be clear about solving this great circle problems, to find out the initial course, final course, distance, and the vertex. Okay. So, okay then. I don't see any no, so I trust you that when you're saying that you have finished those 2 questions. So we'll try to do the other 2 when we meet in the next class, or let us finish the theoretical topics first, and then we'll go on to solving those problems. Chalo, okay then. Enjoy your day. Have a good day. Maybe have a
Thank you,
lecture on
sir.
that. Yeah. Okay then. Chalo, bye.